Hello everyone, how is it going? Welcome back to the channel, and today we are going to carry on discussing cryptography, and in this video we will focus on its evolution in the cryptographic techniques. First, let's look at the evolution of cryptography. We saw all the way back in 1518 a book on cryptography written by Trithemius, where we have our first known example of someone actually documenting this process of cryptography. We also have the work of Blaise de Vigenère, who developed the idea of using many alphabets instead of a single alphabet in what we would call then a polyalphabetic cipher. We also have the work of Sir Francis Bacon, Thomas Jefferson, who developed the Jefferson wheel, the Jefferson cipher, and that really carried forward to the development of a cryptographic device used by the American military in the Second World War, known as the M209 machine. All of these were developments of when we moved from manual to more mechanical process as well. Early cryptography was a manual process. In fact, we still do manual process in some cases today, using things like Vernam ciphers and one-time pads were often done using a manual process. But we saw the development of mechanical types of tools and wheels that could help us then to perform the cryptography in a more, we should say, semi-automated or mechanical sense. We saw the development of the Japanese red and purple machine, which were based on telephone stepping relays. Now we are getting to the area of electromechanical. But of course today we're using various types of scripts, programs and software, and a type of electronic, which is of course incredibly fast and incredibly strong. Now, where's the future of crypto going? We had a lot of discussion about whether or not quantum computing will undermine cryptography, but of the recent presentations by Ron Brevist of RSA was that that's not going to happen. Quantum computing has tremendous potential and tremendous power, but the cryptographic algorithms we use will still survive. Now, there's another term that's used here that can be confusing, and that term is quantum cryptography. That's not the same as quantum computing. Quantum cryptography was based on the transmission of a message over fiber using then light beams, and the idea behind quantum was that you know if a person even tried to read your message. So it would immediately tell you, hey, someone is trying to capture your messages. We've seen several implementations of quantum cryptography already, but they have all been broken. Quantum computing has tremendous potential, and quantum cryptography maybe not so much. But when we took a look at that, we also saw that in the 1940s, Claude Shannon wrote that we should assume our adversary has a copy of our ciphertext and knows our algorithm. So in one way, what is the advantage of knowing that somebody was trying to capture your ciphertext? We should already be assuming that anyway. I hope you enjoyed this video. Don't forget to hit the bell for more interesting content, and thanks for watching. See you next time.